I'm Anil Kumar, and in this video we will understand the basic definition of the discrete function sequence. Now the question here is, explain if the following graphs represent a sequence or not. So you're given two different graphs. You have to explain if they represent a sequence or not. You can pause the video, answer the question, and then look into my suggestion. Now we have dots on this graph which represents some coordinate pairs, and these coordinate pairs could be written in the first part as 0, 4, and then we have here 1, 3. The second one is 2, 2, and then we have 3, 1, and we have 4, 0, right? So 4, 0. So that is representation of the dots which are given on the first graph. The second graph has a very minor difference. It is represented by the set of values. Let me put them in this bracket. So this is represented by the set of values where it is missing one term, but the other terms are 1 and 3, 2, 2, 3, 1, and 4, 0. Now think about it and then answer. Are these both sequences or not? And explain why. Well, let me now give you the answer and then we'll think about the reason. So here we say this is a sequence and this one is not a sequence. Now, can you tell me why it is so? Why it is so? What makes this a sequence and not this? That is a very important question to answer, and then we will move on with sequences. Now think about the definition of the sequence itself. So what is a sequence? Well, let me put it here in writing. A sequence is a discrete function, as the topic says. So we know a sequence is a discrete function. That is first thing we know about a sequence. What else? What else do we know? Now in a sequence, every term is defined by its position. So that means position is important. Position defines the terms, right? So we say this is, let me say this one is my first term, second term, third term, and fourth term. That is how we say position is linked with the value, and that gives you the sequence. Now what makes the second sequence and the first one as not a sequence is still to be answered. What is the main difference, and why do you say that the first one is not a sequence but the second one is a sequence? Well, when we write a set like this, can you tell me what is a domain? Domain in this case is all the x values, and the domain here is 1, 2, 3, 4, and so on, correct? Well, we'll just put 4 since we have 4 numbers here. So, and in the first case, what is the domain? The domain in the first case is 0, 1, 2, 3, and 4. Now that gives you an idea that the first one is not a sequence, but the second one is a sequence. And the reason is, as now you guessed it, domain of a sequence is natural numbers, right? So that is third point, and that is domain of a sequence is set of natural numbers. Okay, so domain of a sequence is a set of natural numbers. Natural numbers do not include 0, correct? Natural numbers are 1, 2, 3, 4. Got the point, right? So domain of a sequence includes just a set of natural numbers. So this is indeed a very, very important thing to remember when we are working with discrete functions and especially sequence. So domain of a sequence is a set of natural numbers, which I mean to say is numbers like 1, 2, 3, 4, and so on. Do you get the point? 0 is not a natural number. When we include 0, it becomes a set of whole numbers, correct? So it is always, when we are looking at a sequence, it is a set of discrete points where the domain is set of natural numbers. I hope that helps. Thank you and all the best.